Good morning, ladies and gentlemen. My name is Jules Feldhacker, and I am honored to be your moderator for the day. Through the support of the Department of Defense's Smart Scholarship Program, I am currently pursuing my Ph.D. in Aerospace Engineering at the University of Colorado, Boulder, as a graduate research associate in the Colorado Center for Astrodynamics Research. Over the past several years, in addition to research in the area of trajectory design for human missions at L2, I have had the opportunity to intern at both NASA Langley Research Center and Air Force Space Command, to participate in graduate-level curriculum development in commercial spaceflight operations through the FAA's Center of Excellence for Commercial Space Transportation, and to serve on the board of directors for the nonprofit STEM outreach organization We Want Our Future. I would like to thank the Space Foundation for the opportunity to be here today as a part of its New Generation Space Leadership Program, which enables younger members of the space industry to gain exposure to and mentorship from some of the industry's senior leaders. It is now my pleasure to introduce our next featured speaker, Dr. George C. Nield, Associate Administrator for Commercial Space Transportation at the Federal Aviation Administration. With more than 30 years of aerospace experience at the Air Force, NASA, and in the private sector, Dr. Nield is uniquely qualified to lead efforts regarding the commercial launch industry, which affect both established providers and emerging players. Dr. Nield, welcome back to the Space Symposium.
Well, thanks, Juliana, and good morning, everyone. It's always a thrill for me to have a chance to participate in the program here at this very special event, especially since there's so much going on right now in commercial space. I have the privilege of leading the Office of Commercial Space Transportation, one of the 4 lines of business in the FAA, along with aviation safety, airports, and the Air Traffic Organization. We have a twofold mission. First, to ensure public safety during commercial launch and reentry activities, and second, to encourage, facilitate, and promote commercial space transportation. As you can imagine, this is a very exciting time for us. What I'd like to do this morning is to spend a few minutes talking about what I see happening in commercial space, both now and in the years ahead. It's hard to believe, but it's been more than a year and a half since the space shuttle flew its final mission. And in spite of what some people may think, NASA has not closed its doors, and the United States still has a robust space program. Things have started to change, however. For the first 50 years or so after the dawn of the space age, almost every space activity, every milestone, and every accomplishment was under the direction of the federal government, usually NASA or the Department of Defense. Of course, there were contractors involved, but in almost every case, the vehicles were designed, built, and operated under government contract and direction to carry out government missions. Going forward, that's not always going to be the case. In the future, private industry is going to be a key player, especially if we're talking about transportation to and from low Earth orbit or for suborbital activities. Why do I say that? What's causing the change? Well, there are actually a number of factors involved. First and foremost among them is the current budget environment. There just isn't enough money for NASA to do everything it would like to do, from aeronautics research and earth science to operating the International Space Station to exploring the solar system, if we continue in a business-as-usual mode. But if NASA can get comfortable with turning over to industry some of the activities that are well understood, like sending cargo and astronauts into low Earth orbit, something that we have been doing for more than 50 years now, then it can devote its time, its energy, and its limited resources to working on new challenges, like visiting an asteroid or sending astronauts to Mars. One of the things that is enabling industry to efficiently tackle aerospace design problems is the amazing progress that's been made in technology over the last several decades. Of course, the law of gravity and the rocket equation haven't changed a bit, but the way we work on a project today has changed tremendously, with desktop computers, email, and video conferences, and with computer-aided design and computational fluid dynamics. We're also starting to see some extremely supportive government policies which recognize the importance of a healthy aerospace industrial base and which encourage government agencies to consider backing off of the traditional requirement for strict government oversight of their contractors in order to reach the potential benefits of lower costs and increased innovation. Finally, in an era when it's often said that a single individual can't really make a difference in this world, we're seeing a number of people who are passionate about space and who are putting their money where their mouths are in a manner that is significantly impacting the U.S. space program. One of the precursors to the imminent emergence of commercial space took place back in October of 2004, when Burt Rutan and his team at Scaled Composites successfully flew Spaceship One to the edge of space, twice in a 2-week period, thereby winning the $10 million Ansari XPrize. That was really the existence proof of the fact that these days, it doesn't necessarily take a government with thousands of people and billions of taxpayer dollars in order to build a spaceship. Now, the critics have questioned why nothing has happened since that time, as if this new, more entrepreneurially oriented industry could be built overnight. There really has been a lot going on over the last 8 years, but as this audience knows all too well, spaceflight is hard. It involves risk, and it's expensive. Even the large established aerospace firms who have decided to embrace some of the new paradigms and compete for some of the new commercial markets will take a while to incorporate the new ways of doing business into their corporate cultures. I mentioned that we have recently had very supportive national policies. The current National Space Policy, which was published on June 28, 2010, is quite clear about how we as a nation intend to treat the commercial space sector. For example, it notes that the United States is committed to encouraging and facilitating the growth of a U.S. commercial space sector that supports U.S. needs, is globally competitive, and advances U.S. leadership in the generation of new markets and innovation-driven entrepreneurship. Something that I've found very interesting has been the ongoing impact of wealthy individuals. According to the Forbes 2013 Billionaires list, there are currently 1,426 billionaires worldwide, less than a third of whom live in the U.S. But if you scan the list, there are a number of folks who will be familiar to those of us who work in aerospace. Paul Allen, who helped to support Scaled Composites efforts in the XPrize competition and who recently formed the Stratolaunch enterprise, is reported to be worth $15 billion. Jeff Bezos, the founder of Amazon.com, supposedly has more than $25 billion to his name. Richard Branson, who formed Virgin Galactic with the intent of it becoming the world's first space line, is said to have a worth of $4.6 billion. And Elon Musk, the founder, CEO, and chief technical officer of SpaceX, apparently has amassed $2.7 billion for a nest egg. There are a number of others who did not make the Forbes list, but who have nonetheless not been shy about spending their personal savings on aerospace projects. Among them are Robert Bigelow, who made his money in the hotel business, but who has formed a company that is in the process of building inflatable modules that can be used as part of a commercial space station. Dennis Tito, the founder of Wilshire Associates, and arguably the world's first space tourist, who paid more than $20 million of his own money to fly to the International Space Station. And John Carmack, the video game software programmer, who founded Armadillo Aerospace, the winner of NASA's Lunar Lander Challenge back in 2008. So those are some of the factors that I think will lead to an increased role for industry in our nation's space program. But this is not an all or nothing proposition. If we can find the sweet spot between government needs and industry capabilities, I think we can have a real win-win partnership with a genuine opportunity for progress. Government brings to the table the impressive expertise of its workforce, more than 50 years worth of real-world space experience, and a continuing need for space products and services. On the industry side, most people would acknowledge that given the appropriate kind of contract mechanism and program management, private companies can usually produce a product for lower cost than can the government. Assuming they are allowed to do so under their government contracts, they would probably also have a higher likelihood of being able to incorporate increased innovation in their designs, rather than sticking with the way we have always done it. In addition, given how risk-averse that we have become in most government programs today, I think industry is best suited to help us find the proper balance between risk and reward on high-tech programs. And finally, going forward, industry has an opportunity to inspire both students and the general public through its rocket launches and space operations activities. Now, of course, the government can do that too when it is flying. But with the Space Launch System not scheduled for its first crewed launch until 2021, anyone who goes to an American rocket launch in the next several years is going to be watching a launch vehicle and a spacecraft built and operated by American industry. Looking at the various programs that are currently underway and the plans that have been announced, I see three different kinds of commercial space missions taking place over the next 10 years or so. Missions intended to provide services to the government, such as transporting cargo or crew members to the International Space Station. Missions that take advantage of previously demonstrated technologies, but with new vehicles and new markets, such as suborbital space tourism. And missions related to exploration, with examples ranging from lunar rovers to Mars flybys. A perfect example of a commercial services arrangement is NASA's Commercial Cargo Program. Under the Commercial Orbital Transportation Services, or COTS effort, for an $800 million investment, the nation will end up with 2 new rockets, 2 new spacecraft being developed, plus the supporting ground infrastructure and mission control capability to go with them. What a bargain. And after demonstrating that they can do the job, SpaceX and Orbital have signed fixed-price contracts to provide 20 cargo delivery flights to the ISS. SpaceX has already successfully demonstrated its Falcon 9 rocket and Dragon spacecraft and has made 3 round trips to the International Space Station. Orbital Sciences has successfully completed a hot fire of its Antares rocket on the launch pad at Wallops, and they hope to conduct an initial test launch as early as next week. If all goes well, the follow-on flight, which will include the Cygnus spacecraft actually berthing to the ISS, could occur later on this year. With the space shuttle having been retired, the only way we have to get our astronauts to and from the space station is by hitching a ride on the Russian Soyuz at a cost of more than $60 million per seat. NASA is currently working with 3 different American companies who are interested in taking over that task: Sierra Nevada, SpaceX, and Boeing. NASA's current target date for one or more of these firms to deliver NASA astronauts to the station is 2017. But that is highly dependent on how much funding Congress is willing to provide for the program in NASA's upcoming appropriations. NASA and the FAA have been working together very closely on the Commercial Crew Program, and one of the issues that we've had to resolve had to do with FAA licensing. Under current law, all U.S. launches need to have an FAA license in place unless they're being conducted by and for the government. The commercial crew launches are clearly being conducted for the government. However, they're not being done by the government, hence a license is required. To emphasize that point, Bill Gerstenmaier and I last year signed a memorandum of understanding on commercial human spaceflight that established the intent for all operational missions to the ISS to be licensed for public safety by the FAA. Under the agreement, NASA will retain responsibility for crew safety and mission assurance. Let's take a look at some of the progress being made by the companies involved. SpaceX has been busy carrying out cargo delivery missions to the ISS, but in their spare time, they've been trying out vertical takeoffs and landings with a rocket-powered system they call Grasshopper at their test site in McGregor, Texas. The tests are intended to eventually allow the first stage of their Falcon 9 launch vehicle to fly back to the launch site for refurbishment and reuse. They have a ways to go to get to that point, but what they have accomplished in the test to date is extremely impressive. Boeing is continuing to mature the design of its CST100 spacecraft and has already conducted parachute tests and demonstrations of the airbag landing system. Sierra Nevada Corporation has completed captive carry tests of its Dream Chaser vehicle by flying it underneath a helicopter. They hope to conduct a series of automated approach and landing tests out at Edwards Air Force Base later on this year. And United Launch Alliance, the launch operator of choice for both Boeing and Sierra Nevada, has continued to look at the implementation of an emergency detection system. They've also continued to rack up an enviable success record with launches of the Atlas V and the Delta IV. And by the way, the Delta IV Heavy is scheduled to be used in an FAA licensed test launch of NASA's Orion spacecraft in September of 2014. NASA recently announced that it had awarded a $17.8 million contract to Bigelow Aerospace to attach what will essentially be an extra room to the International Space Station. The Bigelow Expandable Activity Module, or BEAM, will remain attached to the station for a 2-year test period, which should allow us to learn a lot about how inflatable modules can be operated in a space station environment. Once the testing is complete, I suspect that Bigelow Aerospace will proceed with the deployment of its own commercial space station, servicing both industrial research teams and international governments that may not already be a part of the existing ISS partnership. Switching to the Suborbital Arena, our office is currently in discussions with about a half a dozen different companies that are in the process of designing, building, and testing vehicles that can take people up to the edge of space, where they will be able to look out the window and see the black sky and the curvature of the Earth and experience the magic of weightlessness. Based on the number of people who have already bought tickets or put down hefty deposits, it looks like the market for space tourism is going to be quite healthy. One of the front runners is Virgin Galactic, which is already working with scaled composites in flight testing the White Knight II carrier aircraft and the Spaceship Two spacecraft. Spaceship Two has successfully completed more than 24 glide flights, and the first rocket-powered tests are expected later on this spring. Once the flight tests are complete, Virgin will be moving the operations out to Spaceport America in New Mexico, which will be the primary location for the initial commercial operations. Both the runway and the combination hangar and terminal facility are pretty much complete, so the folks in New Mexico are eagerly awaiting the start of commercial operations. Altogether, there are 8 FAA licensed spaceports in the US. Those are the ones shown in blue on this chart. But we have recently been contacted by state and local officials in Alabama, Georgia, Texas, Colorado, and Hawaii, all of whom want to pursue the possibility of building a spaceport in their respective states. NASA has contracted with 6 different launch operators as part of its Flight Opportunities Program to offer regular and frequent opportunities to conduct suborbital scientific research. Given the lower cost that should be possible with what are essentially reusable sounding rockets, this program has a lot of potential to energize space-related scientific research. Several of the suborbital vehicle developers are already looking at how to broaden their markets to do more than just space tourism or suborbital science. For example, Virgin Galactic is planning to use its White Knight II carrier aircraft in conjunction with an expendable upper stage they call Launcher 1 in order to take small satellites all the way to orbit. Paul Allen and his team at Stratolaunch are planning to use the same basic approach, but on a much larger scale. The carrier aircraft for this venture will be the largest aircraft ever built, with a wingspan of 388 feet. Scaled Composites is under contract to build the aircraft, which will be powered by 6 engines from Boeing 747s. The launch vehicle was originally to be built by SpaceX, but Orbital Sciences has now been given the task. Design work for these systems is now well underway, and there's a huge new hangar that has been constructed out at Mojave to support the manufacture and assembly. Although many people assume that exploration is an area in which we should expect government efforts to predominate, we're starting to see quite a few private sector initiatives as well. The Google Lunar XPrize is offering $30 million in prizes for non-government teams that can successfully land a rover on the moon, translate over the lunar surface, and send back high-definition video prior to the deadline date of December 31st, 2015. There are currently 23 active teams who are in the hunt, and it will be interesting to see how many of the teams will be able to actually launch some hardware. As a government agency, NASA isn't eligible to compete for the prize money, but they have promised to purchase some of the data that is collected. Space Adventures has arranged all 8 of the orbital space flights that have been completed by private citizens. But if just circling the Earth doesn't provide enough of a thrill anymore, they have worked out a plan with their Russian colleagues to allow 2 people to fly in a modified Soyuz spacecraft as part of an Apollo 8-style fly-around of the moon. The ticket price for that is said to be on the order of $100 million, but they're talking to some prospective customers already. Last December, a group called Golden Spike announced their intention to organize and conduct 2-person scientific expeditions to the surface of the moon. They have an impressive team of board members and advisors, including Jerry Griffin, their board chairman, who has previously served as both an Apollo mission flight director and as director of the NASA Johnson Space Center. They believe that once the initial design and development have been completed, funded by an investment of around $6 billion, individual missions could be accomplished for approximately $1.5 billion each, about the same cost as some of NASA's recent robotic missions. You may recall that on February 15th, a very large asteroid had a close call with Earth, passing some 5,000 miles underneath our geosynchronous weather satellites. On the same day, by coincidence, a much smaller object entered the Earth's atmosphere over Russia and exploded, breaking thousands of windows and sending hundreds of people to the hospital. If we're going to defend the planet against such dangers in the future, we'll need to do a much better job of tracking and identifying near-Earth objects. That's just what the B612 Foundation has in mind. Rusty Schweikert and Ed Lu, a couple of former NASA astronauts, have formed a 501c3 nonprofit organization and partnered with Bigelow Aerospace to build, launch, and operate an infrared telescope that will be able to locate the hundreds of thousands of asteroids that can't be tracked with current telescopes. I earlier mentioned Dennis Tito, the original space tourist, as one of the movers and shakers in aerospace industry today. Well, a couple of months ago, he announced the formation of a group called Inspiration Mars, which hopes to conduct a privately funded 501-day mission to Mars that would allow a two-person crew to fly within 100 miles of the surface of the red planet, using a free return trajectory after launching in January of 2018. There are certainly plenty of skeptics, but when it comes to ambition, audacious plans, and inspiring projects, this one will be tough to beat. Mr. Tito and his team will be giving us an update on their efforts as part of Thursday's agenda, so I hope you'll make it a point to listen in on that session. So that's a quick rundown on some of the things that have been happening in commercial space. I'd be happy to answer any of the questions that you may have, but before I do, I've got a question for you. Are you ready to go? Thank you very much.
Dr. Nield, we do have one question. How many government and support contractors does the FAA have overseeing commercial space?
The FAA itself has on the order of 45,000 employees. In the Office of Commercial Space Transportation, we have 75.
Thank you.